Okay, let's talk about this. At x values where a function is continuous, now right here, this is a very important sentence because this is our condition. If this condition is not met, then this statement is not true. So whenever we want to use this statement, we have to prove that this condition is met first. Now, if this condition is met, so if the function is continuous at the x value, then we can find our limit by direct substitution, just plugging that x value in, and that is our answer. So let's look at this example. Limit as x approaches 3. So we need to check this condition first. We need to ask, is this function continuous at x equals 3? That's what we need to know. To prove that, we need to ask, are there any, go through our discontinuities. Holes at 3? Are there any vertical asymptotes at 3? Or are there any jumps at 3? And if the answer to all three of those is no, then we know it's continuous. So think of 3x squared plus 2. That's going to be a parabola moved up 2, made skinny. If I look at 1, 2, 3, and in fact, if I look at this whole graph, are there any holes in this parabola? Nope. Any asymptotes in this parabola? Nope. Any jumps in this parabola? Nope. So that informal definition, I can take my pencil and go along this whole parabola without ever having to lift it. So this whole parabola is continuous. So is this continuous at x equals 3? Yes. There are no discontinuities, therefore it is continuous. Now, because it is continuous at x equals 3, that means we have met our condition, so we can find our limit by direct substitution. So that means just plugging 3 in for our x values. So 3 times 3 squared plus 2, 3 times 9 plus 2, 27 plus 2. So our limit is 29. Let's try this one as a class, and then I'll have you try this one on your own. Let's look at number 16 now. We have the limit as x approaches 1. So I'm going to ask for our condition, is this continuous at x equals 1? To know that, I need to see if I have any discontinuities. So are there any holes at 1? Are there any vertical asymptotes at 1? Or are there any jumps at 1? To answer those, I need to simplify this function. So I'm going to simplify that up here. Limit as x goes to 1 of x squared plus x over x plus 1. I can simplify this by factoring out an x in the numerator. And look at that. I have a factor on top and bottom that cancels. Anytime you have a factor that cancels, that is a hole, wherever that equals 0. So I have a hole at x equals negative 1, because that's what makes that factor 0. Then I can simplify this, and I get that. Now that I've simplified this, now let's talk about this. Do I have any holes at 1? No, because my hole is at negative 1. Do I have any vertical asymptotes at 1? To know that, I look in my denominator and see if there's anything that makes the denominator 0, because that's undefined. I don't have a denominator in this simplified 1, so no vertical asymptotes. And do I have any jumps at 1? No, jumps will usually happen with piecewise functions. I don't have a piecewise function for this one. So is this continuous at x equals 1? Yes, it is. There are no discontinuities. So because it's continuous at x equals 1, I can directly substitute 1 either into my original equation or my simplified equation. Either one will work. And I'll show you. 1 squared plus 1 over 1 plus 1. That's 1 squared plus 1 is 2 over 2, which is 1. Or if I just plug 1 into my simplified one, I still get 1 either way. So knowing that, I want you to look at number 17. Pause the video, try it out, and then we'll come back and I'll show you the answer. Okay, number 17. We needed to know, is this continuous at x equals pi thirds? So I have my graph here. My amplitude is 1, the number in front. No vertical shift. My period is 2 pi because it's a cosine, divided by 2, the number in front, which gives me a period of pi, and no horizontal shift. So when I graph this, it's pi wide, and it goes up to 1, down to -1. And I have my C wave. And now I'm looking at pi thirds. So I have pi thirds here. Do I have any holes right there? Nope. Do I have any vertical asymptotes there? Nope. And no jumps. So this is continuous at pi thirds. So I plug pi thirds into my equation. Simplify, I just typed it into my calculator. Got -1/2. So that is it for direct substitution. In the next video, we'll talk about piecewise functions.